On the opposite side of the moon, the half that no one on Earth can ever observe, sits the biggest impact crater in our entire solar system. This massive scar is large enough to contain entire continents. In this region, sunlight cannot penetrate the deepest holes in the ground. Temperatures drop lower than those on Pluto. Ice that formed before life existed remains untouched for billions of years. This concealed face is not shadowy, but it is peculiar. This place serves as a storage chamber of space history. It contains impact marks, ghostly magnetic traces, and time frozen in place. People who flew around it described its barren magnificence. The location possesses silence so complete that the entire cosmos becomes audible. Despite this quiet, it also displays violence so intense that it permanently changed the moon. The opposite hemisphere is more than just a lunar secret. It represents an unanswered question for humanity. If you like the content, do not forget to subscribe to the channel and leave a like. Get ready for an exploration into a hemisphere that lies beyond what we can see, beyond quiet, beyond what we can fully grasp. Our journey starts now. The moon floats above us as a steady presence. It acts like a dim lamp that helps travelers at night. It has given inspiration to writers of poetry. It quietly observes the ocean tides and the passage of time. Still, there exists a fact so unusual and so opposite to what seems natural that people did not discover it for hundreds of years. The truth remained concealed even though it was always visible. Wherever you stand on our planet, you will never observe one half of the moon. This does not happen because that side is shadowy. It does not occur because the moon is timid. This happens because of a gentle bond created by gravity. This bond keeps the moon's appearance permanently directed toward us. People call this effect tidal locking. It is like a cosmic hug where spinning and circling match in flawless harmony. Because of this, one half always looks at Earth while the other half turns away into secrecy. Picture yourself holding a coin between your fingers. Now turn your hand while you walk in a circle around a candle flame. No matter how you rotate, one face catches the light while the other drifts away unseen. The moon behaves in this same way. The time it takes to rotate, roughly 27.3 days, matches exactly with how long it takes to orbit around Earth. To people who lived in ancient times, the face of the moon appeared unchanging. Its features looked fixed like a mask that never changed in the sky. The figure people saw in the moon observed every generation. Meanwhile, its hidden twin never showed itself. A false belief took hold that the half turned away must be covered in constant darkness. People spoke in hushed tones about the dark side of the moon. They felt wonder as if it were some cursed wastelands where the sun never touched anything. The reality is both more normal and more amazing. Every section of the moon gets light at some point. Daytime on the opposite side lasts 2 Earth weeks. This is followed by 2 weeks of nighttime. The so-called dark side receives no less light than the side we know. It is only concealed, unable to be reached by eyes alone. For thousands of years, humans looked upward and pondered what existed beyond the visible edge. Did creatures live in its black seas? Did mountains taller than Olympus rise in unknown places? Could the surface be as smooth as glass, or rougher than the scars visible from Earth? Human imagination created every possible picture. People who studied the stars looked through their telescopes but could see nothing beyond that edge. The curved border of the moon that we can observe, called the lunar limb, showed only a tiny strip of land. Everything else stayed veiled. It seemed as if the moon itself refused to share its secrets. In the year 1609, Galileo Galilei pointed his simple telescope toward the moon. He showed mountains, valleys, and craters on the side facing us. However, Even he confessed that the concealed half was beyond what he could reach. Scientists who came after Galileo drew maps of the visible face with beautiful precision. They gave names to the Maria, calling them seas. They named craters after scholars and holy people. They named bright highlands after kingdoms of light. These astronomers could measure things, make predictions, and create charts of eclipses. Yet they stayed blind to the other half. To them, the opposite side could have been the surface of a completely different world. The peculiar truth about tidal locking does not belong only to our moon. Throughout space, numerous satellites abound in similar embraces. Pluto and its moon Charon show this pattern. Many of the inner moons of Jupiter display it too. Even worlds that orbit very close to their stars might become tidally locked. These worlds might show one half in constant blazing daylight and the other in eternal night. This pattern develops from friction. It comes from tides that were created long ago when the moon spun faster. Earth's gravitational pull stretched the moon like soft clay. Across millions of years, energy drained away. The moon slowed down until its spin matched its orbit. It locked into the pattern we observe today. What does it mean to live on a world where half of your companion never reveals itself? For early humans, it meant mystery, legend, and imagination. People pictured gods or demons hiding there out of sight. For scientists, it meant an unsolved puzzle. It was like a book with only half the pages written. It was a locked library sealed with cosmic wax. For dreamers, it meant the ultimate frontier. It was a place so close yet completely unreachable until machines and rockets could break through the barrier. When the 20th century finally arrived, curiosity turned into urgency. Countries raced to launch machines into orbit. They did this not just to compete, but to answer questions that went back to ancient times. In October 1959, a Soviet spacecraft named Luna 3 swung around the opposite side. It captured the first glimpse humanity ever had of that concealed terrain. The photographs came out grainy, blurred and pale. They looked like half-forgotten dreams, but they carried tremendous importance. For the first time, humanity looked upon the opposite side. The contrast was shocking. Where the side facing us displayed dark Maria, which are smooth plains of hardened lava, the opposite side was almost entirely rugged highlands. It was covered with craters stacked upon craters. The difference was so extreme and so unbalanced that scientists could hardly believe what they saw. However, before Luna 3 existed, before astronauts and spacecraft, before all the instruments that would follow, there was only mystery. There was the knowledge that a heavenly body hung over our heads. Half was visible, half was concealed. The locked face was not darkness, yet it was unknown. Perhaps that is its greater power. What remains unseen is always more attractive, more unsettling, more able to create both fear and wonder. Here we find the first contradiction about the moon's concealed side. It receives as much light as any landscape on Earth, but to us, it stayed in shadow. This contradiction became fuel for legends. It sparked stories of secret societies. It led to whispers of alien bases. Even today, conspiracy theories hold on to the idea that something extraordinary hides just beyond what we can see. Yet reality, as science would demonstrate, is more unusual and more magnificent than fiction. When Apollo astronauts circled the moon, they talked about the strange silence when their radios stopped working. Earth disappeared behind lunar rock. During those minutes, they were truly isolated. They were protected from all human communication. They floated above an alien land that no eye had seen directly until that moment. Michael Collins circled alone in the command module of Apollo 11. His crew members walked on the side facing us. Collins became the loneliest human in history. Yet he described the opposite side not with fear, but with amazement. He felt a respectful silence that matched the stillness below. The locked face tells a story of opposites. It shows the difference between legend and reality, between shadow and light, between what is familiar and what is mysterious. It teaches us that what we cannot see often pulls most strongly on our imagination. It also teaches us something about the rules of physics themselves. Gravity shapes time and rotation. It creates the destinies of worlds. Our journey begins here at the edge of mystery. We stand at the border of a frontier that once seemed impossible to reach. The opposite side is more than just terrain. It serves as a mirror. It reflects back our own desire to know things. It shows our need to pierce shadow with light. The locked face calls to us. It whispers secrets through stone and silence. The covering has only partly lifted. The questions it creates still grow deeper. What forces carved such a difference between the two halves? What do the craters and scars hide about the moon's violent history? What does the silence of its concealed face tell us about the universe itself? These are the threads we now follow, one step at a time, into the lunar night. Long before machines broke free from Earth's hold, humanity stared upward and imagined. For as long as people have lit fires in the darkness, there have been watchers. Eyes remained fixed upon the pale sphere rising from the edge of the world. Herders, poets, sailors, and astronomers all tracked the moon's cycle. They noticed how it grew larger, became smaller, and repeated with clockwork accuracy. Yet no matter how sharp the eye or how polished the viewing glass, the concealed face stayed beyond sight. This was a frustration woven into the very nature of human curiosity. Through ancient legends, cultures invented stories to explain what they could not see. To some people, the concealed half of the moon served as a dwelling place for gods. It contained glowing halls where deities held meetings beyond human view. To other people, it was a shadow realm. It was home to monsters, spirits, or the souls of the dead. Legends filled the empty space left by absence. The mind cannot resist creating images where the eyes cannot reach. The Babylonians drew charts of eclipses. The Greeks thought deeply about the moon's changing phases. The Chinese wrote tales of Chang'e, the goddess who lives upon the moon. Yet none of them could describe what lay beyond the edge. The Roman scholar Pliny the Elder once wondered about the moon's surface. He admitted his ignorance of what lay concealed. The centuries moved forward, bringing glass lenses and stone observatories. Still, the other half remained a blank canvas. In the year 1609, Galileo raised his simple telescope. He destroyed false beliefs about a perfect heavenly sphere. His drawings showed rough mountains and deep valleys on the side facing us. He traced shadows along crater edges. He measured the heights of peaks by looking at the lengths of their shadows. He declared that the moon was not an ethereal light, but a world made of stone and dust. However, even with this revolutionary discovery, half of that world stayed closed to him. His telescope, though groundbreaking, could not bend the rules of orbital geometry. Generations of astronomers came after him. Johannes Hevelius created maps of the side facing us in the 1600s with remarkable precision. Giovanni Battista Riccioli gave names that remain in use today: Mare Tranquillitatis, Oceanus Procellarum, Mare Imbrium. Each name was a ceremony for the visible face. Each was a claim of knowledge over what was seen. Yet all their maps stopped at the same invisible border. It was a jagged line where the moon turned away. There were hints, however. There were tantalizing glimpses because of a wobble called libration. The moon sways slightly as it orbits. This allows observers on Earth to see up to 59% of its surface over time. But those extra 9% were like peering around the corner of a locked door. People saw fragments of unfamiliar terrain. They saw partial craters and stretched mountains. Nothing was complete. It was enough to cause frustration, but not enough to bring satisfaction. By the 19th century, telescopes had grown enormous. Observatories sat high on mountains. Hope remained that the opposite side might show itself through some clever trick, yet it stayed unseen. Astronomers drew perfect maps of the side facing us. Every crater was catalogued. Every shadow was measured. The opposite side remained a blank oval on every chart. It was a space saved for imagination. And imagine they did. Writers and dreamers filled it with invention. In 1865, Jules Verne wrote From the Earth to the Moon. In its sequel, he placed his characters in lunar orbit. He imagined what they might see. But Verne's imagination was limited by his time period. He pictured landscapes that continued smoothly with those already known. He pictured Maria spreading endlessly across both halves. He had no proof to suggest otherwise. It was not until the middle of the 20th century that human eyes, indirectly through cameras, were finally allowed a glimpse. On October 7th, 1959, the Soviet probe Luna 3 completed a maneuver that brought it behind the Moon. Its mission was simple but daring. Take photographs of the concealed half and send the images back by radio. For days, scientists and engineers waited. The probe's crude film developed on board. It was scanned line by line. The data beamed through empty space back to Earth. The first images were blurred and ghostly. They looked like half-forgotten dreams, but they carried the weight of revelation. For the first time, humanity gazed upon the opposite side. The difference was startling. Where the side facing us was covered by vast dark plains, the opposite side was almost entirely rugged highlands. It was a chaos of overlapping craters. Only a few small maria appeared. The largest was later named Mare Moscoviense. It was as though the Moon wore two faces. Each was carved by different histories. The reaction among scientists was immediate and electric. Why such stark difference? Why had lava flows smoothed the side facing us but avoided the opposite? Questions multiplied faster than answers. The concealed half had become visible. Yet in being revealed, it became more mysterious. For ordinary people, those images were something almost mystical. The phrase "dark side of the Moon" lingered. But now, with photographs in hand, it became both a poetic metaphor and a scientific curiosity. People saw not darkness but scars. Craters were piled upon craters. It was an ancient battlefield frozen in silence. Still, the desire for direct vision remained. Cameras were intermediaries. Humanity longed to send people. They wanted to let human eyes absorb the sight. That dream waited until Apollo. But before astronauts could circle behind the Moon, the world had to sit with the grainy images. They puzzled over the strange difference. They imagined what it would feel like to orbit through the silence where Earth could not follow. One of the strange things about those early photographs was the sense of isolation they gave. Unlike the familiar face we all recognize, with patterns that look like rabbits or faces, the opposite side was alien. It had no friendly features. It had no sea shaped like recognizable things. It had no familiar landmarks. It was as though the Moon hid its true self. That self was harder, harsher, more severe. Speculative thinkers wondered if such a surface could hide resources. Might its roughness conceal caverns or ice? Others imagined stranger possibilities. They thought of alien outposts and secret structures masked by craters. The lack of clarity left space for fantasies. Even with evidence present, imagination held on to what was unseen. Yet beneath the speculation, the real revelation was simple and profound. The moon is not symmetrical. Its two halves are not reflections but opposites. That fact alone promised to transform lunar science. If one face is familiar and one is alien, then the story of the moon's origin must be more complex than anyone had guessed. So the concealed face, long denied to human sight, finally stepped into view. It did not appear in the gaze of a shepherd or the lens of Galileo. It appeared in the blurred photographs of a machine. The eyes that never saw had at last been given vision. What they found was both unsettling and wondrous. Even now, when we look at those first images, we see more than craters. We see a moment when the boundary of human ignorance shifted forever. The moon stopped being half known. It became whole, yet it became whole while growing infinitely more mysterious. There is a silence deeper than any library. It is darker than any cave. It is older than any cathedral. It is the silence of passing behind the moon. Earth falls away. Every voice, every song, every signal disappears. For those who orbited there, the opposite side was not just landscape. It was a passage through absolute solitude. When the Apollo program began, engineers thought mostly of rockets, flight paths, and fuel. But astronauts thought of something else. They thought about what it would mean to be cut off from Earth. During each orbit around the moon, a spacecraft would spend nearly 50 minutes behind its bulk. It would be unreachable by radio. In that span, the men inside were, for all practical purposes, alone in the universe. On December 24, 1968, Apollo 8 became the first crewed vessel to circle the moon. Frank Borman, Jim Lovell, and Bill Anders slipped into lunar orbit. They watched as Earth vanished behind grey stone. For a moment, radio crackled. Then silence. The signal was gone. The astronauts continued alone in the blackness. When they came back around and Earth rose over the lunar edge, Mission Control celebrated. But for those minutes, a strange stillness pressed against them. It was broken only by the hum of their craft. It was during Apollo 8 that humanity first saw Earth rise. That famous photograph shows our blue planet lifting above the barren lunar edge. Anders described it as the most beautiful sight he had ever seen. Yet for every orbit, that beauty switched with the loneliness of the opposite side. One moment, Earth blazed like a jewel. The next moment, it vanished. It was replaced by endless craters, ridges, and shadows. Apollo 10 repeated the passage. They rehearsed the landing that Apollo 11 would achieve. Astronauts spoke of the opposite side as harsh and alien. Its craters were stacked upon craters. Its mountains were sharp and endless. Then came July 1969 and Michael Collins. While Neil Armstrong and Buzz Aldrin walked upon the side facing us, Collins remained alone in the command module Columbia. He circled above both faces. For nearly 21 hours, Collins orbited in silence. Each time he crossed the opposite side, he vanished from radio contact. He truly became the loneliest man alive. He later wrote that he felt not fear, but awe. I am alone now, truly alone, and absolutely isolated from any known life. I am it. If a count were taken, the score would be 3 billion plus 2 over on the other side of the moon, and 1 plus God knows what on this side. His words carry the weight of solitude, yet they also carry its strange peace. Imagine yourself there. The command module's metal skin separates you from vacuum. Earth is hidden. Stars burn sharp against the black. Below, the opposite side rolls endlessly. Jagged ridges look like frozen waves. Impact scars stretch to the horizon. Plains remain untouched by Maria. You look out. No one has ever seen what you see in this moment, not with their own eyes. For later Apollo missions, the opposite side became familiar, yet it never became less uncanny. Apollo missions 11 through 17 all orbited there. Each time astronauts vanished into silence. Each time they emerged with relief to hear the voices of mission control. They mapped the surface with cameras. They observed craters like Tsiolkovsky with its bright central peak. They noted features that would later intrigue scientists. Yet always the experience was coloured by that unbroken interval of solitude. One astronaut compared the opposite side to an endless junkyard. Impacts had piled debris upon debris. Another spoke of the landscape as a battlefield, frozen in time. Scars from billions of years of bombardment lay untouched. Still another said it was like flying over an alien planet attached to the one we knew. Their words varied, but the tone was always respectful. It was as if language itself stumbled before the desolation. The strangeness of these orbits lies not only in geology, but in human psychology. To be cut off from Earth, from every other living human, is to stand at the edge of comprehension. The astronauts handled it well. They were trained and disciplined, yet they all admitted the strangeness of it. Alone with machines, alone with stone, they drifted through history's first direct contact with the opposite side. The opposite side also carried practical dangers. Without radio, astronauts relied on precise timing. They had to trust in their equipment. If something went wrong while hidden, mission control would not know until too late. Every successful return was a relief. Every signal that came back was a heartbeat restored. Speculation sometimes draped itself over these silences. To those watching from Earth, the minutes of radio blackout seemed mysterious. They became fertile ground for conspiracy. Rumours grew that astronauts had seen strange structures or lights on the opposite side. These were hidden from the public. NASA denied such claims. Astronauts themselves insisted they saw only craters and mountains. The silence itself invited imagination. In absence, myths bloom. Yet the true marvel required no invention. It was enough that human beings had seen what no generation before them had ever glimpsed with naked eyes. It was enough that they had orbited in the shadow of the moon. They tasted solitude more profound than any earthly exile. They were messengers from the unseen. They carried back not secrets of aliens, but revelations of geology, silence, and the deep strangeness of another world. Still, despite the images and the words, the opposite side kept much to itself. Cameras showed the roughness, yet they could not explain why. Instruments on the side facing us recorded vibrations, but their data could only be pieced together into incomplete models. Every orbit deepened the paradox. We saw more yet understood less. The astronauts returned home. Their descriptions were vivid but partial. Photographs filled atlases. The blank half of lunar maps now brimmed with detail. Yet the opposite side remained more than terrain. It was an experience. The experience of solitude. The experience of drifting where no human voice could follow. The experience of becoming a single fragile witness to a half carved by violence and time. In those orbits of solitude, we learned something not only about the moon but about ourselves. We learned the measure of isolation. We learned the strength of imagination. We learned the resilience of those who face the unknown in silence. We learned that the opposite side, once legend, once mystery, was not merely an object to be studied, it was a mirror. It reflected the human condition. It showed our need to know. It showed our fear of emptiness. It showed our respect for what lies beyond reach. Beneath the craters, beneath the dust, beneath the jagged edge of the opposite side, the moon is not silent at all. It trembles. It echoes with whispers, too faint for human ears. Yet these whispers are not too faint for the instruments left behind by explorers. These whispers are moonquakes. They are fragile messages from the depths. They are vibrations that reveal what stone alone cannot show. When the Apollo astronauts journeyed to the moon, they carried with them more than flags and tools. They carried seismometers. These were delicate ears of metal and wire designed to listen. Beginning with Apollo 12 in 1969 and continuing through Apollo 14, 15 and 16, arrays of seismometers were planted across the lunar surface. Their purpose was simple. Their power was immense. They would record every shiver, every impact, every quake. They would send that information back to Earth. For nearly 8 years, until 1977, those instruments listened to the moon's secret heart. The data they returned was startling. The moon, far from being geologically dead, vibrated in ways both familiar and strange. There were shallow moonquakes. Some were strong enough to rattle an entire module if astronauts had been nearby. There were deep moonquakes. They recurred from the same regions, hundreds of kilometers beneath the surface. It was as though the moon breathed in slow seismic rhythm. There were vibrations from meteor impacts. These struck the lunar surface daily. They produced reverberations that rang through stone like a struck bell. There were artificial quakes too. These came from impacts of spent rocket stages deliberately crashed into the moon. Each strike created a seismic echo used to probe the layers within. The strangest discovery was how long the moon rang. On Earth, earthquakes release energy that quickly fades. It is absorbed by water, atmosphere, and softer rock. On the moon, with no oceans to muffle waves, no air to scatter vibrations, no thick mantle of mixed minerals to absorb shocks, quakes echoed and echoed. Scientists who study earthquakes describe the moon as ringing like a bell. A single impact might reverberate for more than an hour. From these whispers, a portrait of the lunar interior emerged. The moon was layered like an onion. A crust averaging 30 to 60 kilometers thick covered it. A mantle lay beneath. At the core, a small, partially molten heart existed. Estimates suggested the liquid core extended about 350 kilometers in radius. This was a fraction of the moon's size, yet enough to reshape theories of its origin. No longer could it be seen as a fully frozen world. Heat still pulsed within. It was enough to stir molten metal. It was enough perhaps to have once powered a global magnetic field. Yet these discoveries carried more questions than answers. Why were deep moonquakes clustered in bands? They repeated with tidal cycles linked to Earth's pull. What did the shallow moonquakes mean? Were they remnants of stress from tectonic activity? Were they fractures opening as the moon cooled and shrank? Why was the opposite side so difficult to study? With seismometers placed only on the side facing us, data from the concealed half remained ghostly. It was reconstructed indirectly. We could hear the moon's voice, but only half of its chorus. Some of the signals were bizarre. Faint tremors suggested structures deep beneath the crust. Perhaps they were remnants of the colossal impact that formed the South Pole Aitken Basin. Other signals hinted at denser regions. It was as though blocks of mantle had risen or sunk. Then there was the question of water. Tiny traces of hydrogen recorded by orbiters, decades later, raised the possibility. Some quakes might be linked to volatiles trapped in rock. Could water, once thought absent, play a role in lunar geology? The moon's quakes also revealed its fragility. Unlike Earth, with tectonic plates shifting across oceans, the moon had no mobile crust. Instead, its surface cracked as it cooled. It was like mud drying beneath the sun. Shallow moonquakes, some reaching magnitude 5 on the Richter scale, suggested the moon continued to shrink. Its crust was crumpling inward by meters over centuries. The opposite side, with its thicker crust, may conceal even more dramatic fractures. Imagine standing on the opposite side when such a quake occurs. No air stirs, no groundwater shifts, no sound travels. The dust beneath your feet shivers, stones clatter. Then the tremor fades into silence. It leaves behind an uncanny stillness. On Earth, earthquakes roar and rumble. They shake the air itself. On the Moon, they pass like ghosts. They leave no sound, only motion in a landscape that soon returns to absolute quiet. Speculative voices have sometimes wondered if these quakes could be signs of something more. Some fringe thinkers once claimed the bell, like resonance of the Moon, hinted at hollowness. They suggested artificial construction. They imagined some ancient artifact of cosmic engineering. Mainstream science firmly rejects such ideas. It points instead to simple physics. It describes a dry, rigid world where vibrations dissipate poorly. Yet the idea lingers in the imagination. It is a reminder that mystery always feeds invention. Still, the true wonder is not in speculation, but in what seismology revealed. The Moon's quakes told us that it is alive. It is not alive in the lush sense of oceans and forests. Yet it is alive in the quiet persistence of motion, contraction, and heat. They told us the Moon is not finished. It is not static. It is still evolving in slow, silent ways. They also told us something of ourselves. It was only by carrying instruments across the void, by planting them in alien dust, by listening patiently for years, that we could hear the whispers of another world. Those instruments became our ears. They were stretched across space, waiting for tremors that spoke of a hidden heart. The opposite side, though less directly measured, remains an open question. What seismic stories does it hold? Do its thicker crust and immense basins create different patterns of quakes? Might it conceal clues to the earliest collisions that shaped not only the Moon but Earth itself? With only half the Moon's voice recorded, the rest still calls from silence. So the seismometer's legacy is both revelation and longing. They unveiled a world more complex than imagined. It was layered and restless. It echoed like a struck bell. But they also left us with the knowledge that much remains unheard. The opposite side whispers secrets still waiting to be captured. In those seismic tremors, faint and fading across billions of years, we sense the heartbeat of a companion world. It is steady, fragile, ancient. We lean closer, listening for more. If the opposite side of the Moon could speak, its first words would be a cry from impact. For here, more than anywhere else on its scarred body, the evidence of ancient bombardment remains written like scripture. Every ridge, every basin, every fractured plane testifies to a time when the newborn solar system was a storm of stone and fire. Among these scars, one stands above all others. It is a wound so vast it redefines the scale of violence. The South Pole Aitken Basin stretches nearly 2,500 kilometers from rim to rim. It plunges more than 8 kilometers deep. It is one of the largest impact structures in the entire solar system. Imagine a crater that would span the United States. Picture one that could swallow Europe whole. Its rim circles mountains taller than the Alps. Its floor sinks deeper than the Grand Canyon. If Earth bore such a scar, it would define continents. On the Moon, hidden on the opposite side, it remained invisible until orbiters and instruments revealed its immensity. What does such a wound tell us? It tells us that in the first 500 million years after the solar system's birth, chaos ruled. Planetary embryos collided, asteroids rained down in torrents, worlds were shaped by catastrophe as much as by creation. The impact that carved the South Pole Aitken Basin must have been titanic. A rock, dozens, perhaps hundreds of kilometers across, slammed into the lunar crust with unimaginable energy. The heat would have vaporized rock. It would have melted crust. It would have flung debris into space. Some of that debris may even have struck Earth. Perhaps it carried with it fragments of lunar chemistry that later mingled with our own planet's surface. The basin's interior is unlike anywhere else. Orbital missions such as Clementine, Lunar Prospector, and the Twin Grail spacecraft revealed a complex gravity signature. Mass concentrations were buried beneath layers. They were rearranged. Mantle material was exposed. Instruments that measure light wavelengths detected minerals uncommon elsewhere on the Moon. They found pyroxenes rich in iron. They found signatures of rocks dredged from deep layers. The impact was so powerful it may have punched through the crust. It excavated the mantle itself. It scattered its chemistry across the basin floor. But here lies a paradox. For all its violence, the basin holds secrets that resist easy telling. If mantle material was truly exposed, why does the chemistry remain inconsistent? Some scientists argue that later lava flows buried the deepest scars. Others propose that the mantle's composition itself remains poorly understood. This leaves the basin's evidence ambiguous. The South Pole Aitken Basin is both a window and a veil. It gives a glimpse into the Moon's interior, yet one clouded by later history. Its scale also reshaped the opposite side itself. The basin's shockwaves rippled across the crust. They fractured regions thousands of kilometers away. Strange magnetic oddities appear near its antipode. This is the exact opposite point on the Moon. It is as if the energy of impact focused there. It stirred molten rock. It magnetized surface minerals. The swirls and fields we find in that opposite region may be fingerprints of this ancient catastrophe. Then there is ice. Nestled within the basin's southern reaches are craters so deep their floors never see sunlight. Here, in permanent shadow, temperatures plunge below -230 degrees Celsius. Any molecule of water that wandered into such a trap could remain frozen for billions of years. These molecules might have been delivered by comet, asteroid, or solar wind. These are the coldest known places in the solar system. They are colder even than Pluto's surface. The Lunar Reconnaissance Orbiter's laser altimeter mapped these shadows. Instruments like LCROSS confirmed that ice indeed lingers within them. Thus, the greatest scar of fire became paradoxically a cradle of ice. Imagine descending into one of those shadowed craters. Above, jagged rims blaze with eternal sunlight. These are peaks of brightness that never fade. Below, an abyss of blackness stretches before you. It is a pit where no dawn will ever come. Dust lies brittle. It is frozen like glass. Beneath it, grains of ice glimmer faintly. They are relics of collisions long past. Each grain is a time capsule. It preserves chemistry older than human history. It is older than Earth's first forests. Perhaps it is even older than life itself. To walk there would be to touch water delivered from the stars. This water has never melted. It has never flowed. It has never known the warmth of day. The South Pole Aitken Basin is thus more than a scar. It is a paradoxical temple where extremes coexist. Violence and silence live together. Fire and ice share the same space. Absence and abundance exist side by side. Its depths whisper of catastrophe. Yet they also cradle the very resource that could one day sustain human explorers. In that frozen water lies the possibility of drinking, breathing, even fueling rockets. The seeds of permanence exist on a world that once seemed barren. Speculation stretches further. Some planetary scientists wonder if the impact that created the basin was so colossal it altered the Moon's very balance. Could it be linked to the difference between the side facing us and the opposite side? Did it redistribute mass in ways that left the opposite side thicker and the side facing us thinner? Did this shape the Maria that later flowed? If so, then the Moon we know, with its bright face of seas and its hidden face of craters, is itself a consequence of this single ancient blow. Yet debates persist. Some models suggest the basin did not excavate mantle at all. They say the minerals detected are merely unusual crustal rocks. Others argue over its exact age. Was it formed during the late heavy bombardment around 4 billion years ago? Or was it created earlier during an even more violent time? Each answer carries implications. It affects the timing of bombardments across the solar system. It influences the history of Earth's own surface. It affects the delivery of water and organic materials that may have seeded life. As we circle back to the basin in thought, we find ourselves in awe of its dual nature. It is the Moon's greatest wound and its greatest archive. It is a graveyard of impacts and a reservoir of frozen time. To study it is to study not only the Moon, but the story of planets themselves. We learn how they are scarred. We learn how they endure. We learn how they carry within their wounds the clues to everything that came after. The opposite side wears its history openly. Nowhere does it do so more than here, where a basin holds both the memory of fire and the silence of ice. To look upon it is to understand that creation and destruction are never separate. They are twins born together in the crucible of the early solar system. They still echo in every frozen shadow. Stand at the edge of imagination and compare the two faces of the Moon. On one side, vast dark plains appear. These are seas of solidified lava stretching smooth across the horizon. On the other side, endless mountains rise. Craters are layered upon craters. The landscape appears jagged and chaotic. This is the Moon's greatest riddle. It shows a difference so stark it appears almost unnatural. Why should one half be painted in shadowy seas while the other remains a fortress of stone? Why does the Moon wear two faces? The side facing us, familiar to every generation of humanity, is marked by Maria. Early astronomers misnamed these as seas. They are not oceans but flood basalts. They are vast plains formed by lava that welled up from the interior. It cooled and darkened into iron-rich rock. They spread across lowlands. They drowned older craters. They smoothed scars into sheets of night-coloured stone. They account for nearly 1/3 of the surface on the side facing us. Their shapes form patterns. Cultures across the world have seen rabbits and faces in them. The opposite side is another world. Here Maria are rare. They are scattered only in isolated patches like Mare Moscoviense and Mare Orientale. Instead, mountains dominate. Ridges rise sharp and high. Craters pile upon one another like shattered glass. The surface gleams brighter. It reflects more sunlight because its crust is thicker. Its rocks contain less iron. Where the side facing us suggests fluidity and flow, the opposite side is rigidity incarnate. It is frozen in rough relief. Scientists puzzled over this contrast from the moment Luna 3's photographs reached Earth. Why would the Moon's two halves evolve so differently? For decades, the mystery deepened. Each new mission added evidence, but not resolution. Then seismometers, gravity maps, and orbiting instruments that measure light wavelengths together revealed the outlines of a possible answer. The key lies in thickness. Measurements from Lunar Prospector, the Grail mission, and later instruments showed that the Moon's crust is not uniform. On the side facing us, it averages about 30 kilometers thick. On the opposite side, it doubles. It reaches more than 60 kilometers. Imagine pouring molten lava across two fields. One is covered by a thin layer of soil. The other is covered by a thick slab of stone. In the first, magma bursts through. It spreads in floods. In the second, it is trapped beneath. Its pressure dissipates. Its outflows are rare. Thus, the opposite side's roughness may be the simple consequence of being armoured against its own interior. But why should the crust be thicker there? Some theories point to the moon's violent birth. According to the giant impact hypothesis, the moon formed when a body the size of Mars struck Earth. It ejected debris that came together in orbit. In those first molten centuries, the moon was covered by a magma ocean. As it cooled, lighter minerals like plagioclase floated upward. They formed crust. If cooling was uneven, if Earth's radiation slowed the solidification on the side facing us, then minerals might have drifted. They thickened the shell on the opposite side. In this telling, the difference is a frozen memory of the moon's creation. Another theory suggests a companion moon. Some models propose that after the giant impact, Earth briefly hosted two moons. The smaller one may have collided slowly with the larger one. They merged not with catastrophic violence, but with a gentle splash of rock. If so, the opposite side might be the graveyard of that merger. Its thicker crust would be a relic of a sibling absorbed. Though evidence remains elusive, the theory lingers as a tantalizing speculation. It is a cosmic tale of twins reunited. Even radioactive elements may have played a role. Mapping of thorium, uranium, and potassium shows they are concentrated on the side facing us. Elements that release heat when they decay are found more there. This region is called the Procellarum creep terrain. It may have stayed hotter for longer. This allowed magma to erupt in floods that formed Maria. The opposite side, deprived of such internal heating, cooled into rigidity. It preserved its cratered highlands. In this sense, the moon's two faces are divided not only by crustal thickness, but by energy itself. Open debates remain. Did the South Pole Aitken impact redistribute mass in ways that favoured crustal growth on the opposite side? Did tidal forces from Earth pull molten material preferentially toward the side facing us? Each hypothesis holds fragments of truth, yet no single answer commands consensus. The moon keeps its difference as a lingering riddle. It is half solved, half shadowed. To walk the boundary between the side facing us and the opposite side would be to step across epochs of planetary history. On one horizon, smooth plains glisten with basalt. It is dark glass frozen from ancient fire. On the other, jagged mountains rise. Their peaks are sharp against the void. Their flanks are layered with craters unhealed by lava. It would be like stepping from one planet to another. The transition would be abrupt, startling, absolute. The difference is not just a curiosity, it is a gift. By comparing the two halves, scientists can probe the processes of planetary evolution. Why do some worlds retain volcanic vigor while others freeze? How does crustal thickness shape surface destiny? How do heat, impacts, and radioactivity conspire to sculpt landscapes? The moon, by wearing two faces, offers us a natural experiment. It is a binary world written on a single sphere. Speculative minds imagine what might hide beneath the opposite side's thickness. Do reservoirs of magma remain locked beneath kilometers of crust? Are they waiting for some future tremor to stir them? Could water delivered by ancient comets be trapped in fractures? Could it be sealed away in cold stone? Without direct drilling or seismometers planted across that half, answers remain veiled. The opposite side speaks in silence. We strain to hear its story. There is poetry in this difference. One face is turned toward us. It is softened by flows, almost familiar. Its patterns are etched into every culture's myth. The other is turned away. It is rough and scarred, aloof, unyielding. It is stranger even in its silence. Together they form a duality that mirrors our own existence. We show one side, smoothed and visible. We hide another side, rougher and older, shaped by forces unseen. Perhaps that is why the opposite side fascinates us still. It fascinates not merely because it is hidden, but because it is different. It tells us that even a single world can hold contradictions. History writes itself unevenly. Beauty lies in imbalance. The moon's difference is not a flaw, but a truth. Creation is never uniform. Every world carries within it the memory of how it was made. Invisible forces sculpt the moon as surely as craters and lava do. Gravity, relentless and unseen, leaves fingerprints. These are not etched in stone, but in the paths of orbiting spacecraft. They appear in the subtle tug and tilt of their trajectories. Nowhere is this more apparent than in the strange oddities beneath the moon's surface. These are concentrations of mass buried under ancient basins. They are known as mascons. They tug at anything that passes overhead. The story began in the 1960s. Lunar orbiter spacecraft circled the moon in preparation for Apollo landings. Engineers expected clean, predictable orbits. Instead, they found their spacecraft veering off course. Invisible hands seemed to nudge them. They pulled them down toward the lunar surface. They forced constant corrections. The oddity puzzled flight controllers. Then scientists realized the cause. Beneath certain Maria lay immense regions of denser rock. They were formed by colossal impacts that had once melted and refilled the crust. These mass concentrations, mascons, warped the moon's gravitational field. Picture a trampoline. Its fabric is stretched tight. Place a heavy stone on one side. The surface sags. It bends everything around it. That is what a mascon does to space itself. It creates a localized dimple in the moon's gravity field. It pulls at orbiters like invisible fingers. To land on the moon safely, mission planners had to map these distortions with care. Without correction, spacecraft could drift into peril. Their delicate balances would be upset by forces they could not see. The most famous mascons are found beneath the Great Maria of the side facing us. Imbrium, Serenitatis, Crisium, Humorum. Each is an ancient impact basin later flooded with lava. The heavier rock created hidden anchors of gravity. But mascons are not limited to the side facing us. The opposite side bears their imprint too. Though buried beneath thicker crust, their presence is more subtle. Their signatures were only revealed decades later with advanced instruments. In the 21st century, the Grail mission sent twin spacecraft named Ebb and Flow to orbit the moon in formation. They measured tiny changes in distance between them as they passed over different regions. These changes revealed the most precise gravity map ever made of another world. The results were breathtaking. Mascons appeared not as isolated curiosities, but as widespread phenomena. They were relics of giant impacts that shook the moon's core. The map showed how crust, mantle, and surface interwove. It showed how the moon's interior bore scars as deep as its surface. From these data, scientists reconstructed histories written in gravity. Mascons formed when immense asteroids struck. They hollowed basins and compressed crust. Later, lava flooded the void. It was denser than surrounding rock. It left a permanent imprint. The opposite side's thicker crust explains why its mascons are subtler. Lava could not rise easily to fill craters, so gravity oddities there are weaker, hidden. Yet even in their weakness, they tell stories of forgotten violence. Still, mysteries linger. Why do mascons persist for billions of years when Earth's geology erases such scars? Is the moon's rigidity the reason? It is a world without plate tectonics. Nothing stirs to smooth gravity's wrinkles. If so, mascons are time capsules. They preserve not just impacts, but the physics of a younger solar system. By studying them, we glimpse the era when planets formed amid chaos. Their fates were written in collisions. There is speculation too. Some researchers wonder if mascons affect more than orbits. Could their gravitational quirks influence the distribution of volatiles? Could they guide where water ice collects in polar shadows? Could they even shape the moon's rotation over time? Could they subtly alter its vibration? These questions remain open. The answers are buried as deep as the mascons themselves. To visualize them is to picture ghosts beneath the surface. They are invisible mountains of density. They are silent attractors that curve the very fabric of motion. Stand above Mare Imbrium. You stand atop one of the largest. Beneath your feet, far below the basalt plains, lies a denser core of rock. It is the frozen memory of an ocean of lava that once surged upward. Though unseen, its gravity pulls at you. It tugs at your heartbeat, your breath, your every cell. You feel no difference. Yet spacecraft feel it keenly. They sense it like a sailor sensing hidden currents in a still sea. For astronauts, mascons were hazards. For scientists, they are treasures. They remind us that gravity is not uniform, not smooth, but sculpted by history. They remind us that the moon is not a perfect sphere. It is a world of uneven depths. Impacts and flows reshaped its very weight. They also remind us of fragility. Even a spacecraft armed with equations and engines must bow to the tug of hidden mass. The mascons also teach humility. To map them required patience and precision. It required the careful listening of twin spacecraft, separated by only a whisper of distance. Their findings revealed not just geology, but the poetry of motion. They revealed invisible landscapes as real as any mountain. They showed hidden shapes of gravity that ripple across the moon like tides frozen in stone. Perhaps the strangest truth of all is that mascons, invisible to the eye, have shaped the moon's destiny. Their presence stabilizes orbits. It dictates how satellites circle. It influences how probes land. They may even help explain why the face turned toward Earth has the features it does. Without mascons, Apollo might have failed. Without mascons, our knowledge of lunar history would remain shallower. In their hidden gravity, we find the weight of time itself. So as we journey across the opposite side, through rugged highlands and silent basins, we must remember that beneath our feet lies more than rock. There lies the unseen architecture of mass. There lie the fingerprints of collisions so vast they rewrote gravity. The moon does not merely bear scars on its surface. It carries them in its pull. It carries them in the invisible hands that still reach upward to tug at passing travelers. The opposite side may seem desolate, yet even in its silence, it hums with gravity's hidden hand. In those unseen currents, we sense the truth. Every world is shaped not only by what we see, but by what lies beneath. It pulls quietly, eternally, unseen. There are places on the moon where sunlight has never walked. Deep within craters at the lunar poles, the walls are so steep and the angle of the sun so shallow that no ray has pierced their interiors for billions of years. These are the permanent shadows. They are abysses of blackness so cold they are colder than the outer planets. They are so dark that even starlight seems swallowed. On Earth, shadows are fleeting. They pass as the sun arcs overhead. But on the moon's poles, shadows are eternal. The opposite side contains many of these hidden vaults. Some lie within the vast South Pole Aitken Basin. Others rest along rims of craters, like Shackleton, Faustini, and Haworth. Their darkness is absolute. Their silence is deeper than any night. Here the temperature can drop below -230 degrees Celsius. It is colder than the surface of Pluto. It is colder than the Kuiper belt. At such extremes, atoms move sluggishly. Time itself feels thickened. Anything volatile becomes trapped in place. Water, ammonia, carbon dioxide freeze into permanence. How do we know what lies in such blackness? We cannot see directly. Yet orbiters have learned to listen. The Lunar Prospector mission carried an instrument that detects neutrons. It found deposits rich in hydrogen near the poles. This hinted at water ice. Later, NASA's Lunar Reconnaissance Orbiter mapped the craters with laser altimetry. It traced their walls with precision. It confirmed which interiors never see light. The L-Cross mission deliberately crashed a spent Centaur rocket into one of these craters. It threw up a plume of debris. That plume revealed water vapor and icy grains. In that single moment, the myth of a dry, barren moon cracked. The moon carried reservoirs of frozen time. Imagine stepping onto the rim of one of these craters. Above you, the peaks may bask in what scientists call peaks of eternal light. These are ridges kissed by the sun nearly year-round. Step forward. The ground falls away into darkness so complete it seems bottomless. If you could descend, your helmet lamp would cut a narrow cone into the black. The dust beneath your boots would crunch like powdered glass. If you dug into the soil, you might uncover shards of ice. These are grains untouched since the solar system's youth. This ice is more than a scientific curiosity. It is history, resource, and enigma. It is history because each deposit records the story of water delivered over billions of years. It came by comets, asteroids, and solar wind. It is a resource because water means survival. It is drinkable for astronauts. It can be split into oxygen for breathing and hydrogen for fuel. It is an enigma because we still do not know how much lies hidden. We do not know how pure it may be. Some estimates suggest enough to sustain human bases indefinitely. Others warn the reserves may be patchy. They may be thin layers mixed with regolith rather than pure deposits. The existence of such ice raises questions that stretch beyond exploration. Could water frozen in these polar vaults hold organic molecules? Could it contain precursors of life delivered by ancient comets? Could they preserve chemistry from the dawn of the solar system, unaltered for eons? If so, these shadows are not merely cold traps. They are cosmic libraries. They store pages of a story we have barely begun to read. Yet the mystery deepens. Radar studies sometimes suggest more ice than other instruments confirm. Some craters yield strong signals. Others give ambiguous ones. The distribution is irregular, patchwork. It is like whispers half heard. Why should one crater hoard ice while another remains barren? Did subtle differences in sunlight, impact history, or soil composition decide their fates? Here lies a frontier of science still open. It is an unsolved puzzle suspended in eternal night. Speculative thinkers have dared stranger questions. What if microbial life, once dormant, rode comets and landed here only to freeze in stasis? Could these polar shadows be the closest analogue to archives of panspermia? Could they be capsules of possible biology waiting beneath dust? Mainstream science considers such survival unlikely in the harsh radiation of space. But the shadows themselves offer shielding. They are a natural vault. Whether sterile or not, they remain places where life's building blocks might linger. They wait for us to discover them. The very darkness itself plays tricks on the mind. Without atmosphere to scatter light, the shadows are absolute. Even infrared warmth is scarce. Instruments struggle to see, heat, or probe. To send rovers here requires careful planning. Solar panels fail in permanent night. Nuclear batteries must keep machines alive in unbroken cold. Exploration of these places is not just scientific, it is an engineering odyssey. It is a test of how far we can carry light into endless black. Standing at the rim, you would feel a paradox. The peaks above you glow eternal. They bask in sunshine. Yet just meters away lies a vault of infinite night. The juxtaposition is surreal, almost spiritual. Eternal light and eternal shadow exist side by side. They are divided by a ridge of stone. If there is a temple of extremes on the moon, it is here. Fire and frost meet in silence. For all our measurements, the shadows remain largely unexplored. Rovers have yet to crawl into their depths. Human feet have not touched their frozen floors. We know of their existence, of their promise, of their haunting silence. Yet we have not yet entered them fully. They remain an invitation. Come, descend, discover what has slept untouched since time began. The opposite side's shadows remind us of something profound. The universe hides treasures not in light, but in darkness. To seek origins, we must sometimes step into places where no star shines. We must go where heat itself is banished. Even the coldest vaults may hold the warmest truths. They may hold water, memory, the chemistry of life. As our gaze lingers, we understand the moon is not just a barren rock. It is a keeper of secrets. Some are locked in scars, others are locked in shadows. In those shadows, frozen and eternal, we glimpse the possibility. What was delivered long ago still waits for us, silent, patient, glimmering in the dark. Not all discoveries come gently. Some arrive with violence. Some arrive with the deliberate act of smashing metal into stone to force secrets into the open. Such was the case in October 2009. NASA turned an empty rocket stage into a scientific experiment. They hurled it at the moon's south pole. The mission was called El-Karos. This stands for Lunar Crater Observation and Sensing Satellite. Its goal was audacious in its simplicity. Strike the moon. Stir up a plume of hidden material. Look for water. The target was Cabeus Crater. It is a shadowed depression near the lunar south pole. Its floor lies in perpetual night. It is colder than liquid nitrogen. It is a vault where ice, if present, could survive for eons. The Centaur upper stage of an Atlas rocket, already spent, was directed to crash into Cabeus. It travelled at over 9,000 kilometers per hour. Following it was a shepherding spacecraft. It was equipped with cameras and instruments that measure light wavelengths. It was set to fly directly through the debris plume. It would measure what it found before itself, impacting moments later. On Earth, telescopes turned skyward. NASA streamed the event. They hoped amateur astronomers might even glimpse the flash. Anticipation swelled. Would the moon yield its hidden ice? The strike came on schedule. It was a collision with energy equivalent to several tons of TNT. Dust rose into the vacuum. It was illuminated by the faint glint of sunlight. For many watching, the plume was subtler than expected. It was barely visible in telescopes. Yet the instruments on board the shepherding craft saw what mattered. Water. Not just traces, but significant quantities. Hundreds of kilograms vaporized and revealed in a single instant. It was a turning point. For decades, scientists had debated whether the moon was utterly dry. The Apollo samples gathered from sunlit equatorial regions contained almost no water. This reinforced the idea of desolation. Clementine in 1994 hinted at hydrogen near the poles, yet uncertainty lingered. Lunar Prospector in 1998 strengthened the case, yet skeptics remained. El-Karos changed everything. In the plume's spectrum were the unmistakable fingerprints of water vapor and ice grains. The moon was not bone dry, it was a keeper of frozen treasure. The findings did not stop there. Alongside water were molecules of methane, ammonia, carbon dioxide. There were even traces of organic compounds. The plume was a cocktail of chemistry. It was a frozen pantry of volatiles delivered over billions of years by comets and asteroids. Some molecules may have formed when the solar wind implanted hydrogen into lunar soil. Later, it bound with oxygen to make hydroxyl and water. Others were remnants of impacts preserved in cold shadow. In that single crash, a new picture emerged. The moon was a chemical archive. It was a storage vault of cosmic delivery. The implications rippled outward. For exploration, water meant survival. Future astronauts could drink it. They could grow food with it. They could split it into oxygen for breathing and hydrogen for rocket fuel. A base near the poles could mine ice. It could turn the moon into a refueling station for deeper voyages into the solar system. For science, the volatiles carried information. They told about the history of the solar system. They revealed the frequency of cometary deliveries. They showed the chemistry available on early Earth when life arose. To study the moon's ice was to study the prelude to biology itself. Yet mysteries remained. How much ice exists? How is it distributed? L-Cross sampled only a single crater. It sampled a single point in an immense landscape. Some estimates suggest billions of tons of ice lie trapped in shadows. Others caution the reserves may be patchy. They may be thin layers mixed with regolith rather than pure deposits. Radar reflections sometimes indicate abundance. Sometimes they show ambiguity. The truth remains hidden. It waits for future drills, rovers, and explorers. There is also the question of origin. Did most of the ice come from comets? These comets carried water forged in the outer solar system. Did it come from asteroids, which also harbour hydrated minerals? Did it come from the solar wind, implanting protons that slowly built water molecule by molecule? The chemistry of isotopes may hold answers, yet sampling directly is required. Until then, the ice remains both treasure and riddle. Some voices, speculative and bold, have even wondered whether the moon's ice could carry organic precursors. These would be preserved from ancient impacts. Could amino acids or carbon chains, frozen and shielded from radiation, linger in these shadows? If so, then within Cabeus and its kin might rest molecules that mirror those delivered to early Earth. They could be seeds that once helped spark life. While mainstream science remains cautious, the possibility lends a haunting resonance to those dark craters. They may be libraries not only of water, but of potential beginnings. The crash of El Carros also carried symbolic weight. To smash into the moon for knowledge may seem brutal, yet it reflects a truth of exploration. Sometimes revelation requires disruption. The Centaur stage, once a tool for ascent, became a probe by descent. Its destruction illuminated mysteries unreachable otherwise. From impact came insight. From violence came revelation. Imagine for a moment standing at the rim of Cabeus in the aftermath. The crater floor, invisible in darkness, stirs with dust. It is disturbed by the collision. Particles of ice, unseen for billions of years, glimmer briefly in faint light before settling back into silence. What was hidden rises into view. Then it returns to shadow. It leaves behind data captured by machines. It leaves the knowledge that the moon is not barren after all. For those watching from Earth, El Carros may have seemed a quiet event. There were no brilliant fireworks. There were no visible geysers. Yet in its subtle plume lay a profound truth. The moon carries water. With it comes the promise of futures we had not dared imagine. Bases, fuel depots, laboratories all hinge on those frozen reserves. In discovering them, we glimpse not just survival, but expansion. We see a bridge to the wider cosmos. Still, questions echo. How much water is there? How deep does it lie? Will it be accessible or locked away in ways too costly to reach? What of the opposite side? Are its shadows richer, colder, more abundant than those glimpsed, near the side facing us? These questions remain open, tantalizing. They wait for the next wave of missions. The L-Cross crash was not an end but a beginning. It turned speculation into certainty. It turned debate into discovery. It told us that even in the coldest, darkest places, life's most essential molecule persists. It reminded us that sometimes the only way to learn is to reach with both hands, or in this case, with a rocket's empty shell. Strike the unknown. Force it to reveal its hidden truths. The moon absorbed the blow as it has absorbed countless others across eons. But this time, the impact was not just a scar. It was a message. It was a signal flung across space. The moon keeps water. Through it, the moon keeps the promise of tomorrow. Though the moon shines pale and silent, it bears within it the faded memory of fire and magnetism. Today, the moon is airless and nearly magnetically still. Unlike Earth, with its powerful magnetic shield generated by a churning iron core, the moon has only faint remnants. It has ghost fields scattered across its surface. They are weak and patchy. They are detectable only with instruments. Yet these whispers of magnetism tell us a story as strange as any carved in stone. Once the moon may have had a heart that pulsed with molten metal. It may have had a dynamo alive with electricity. When Apollo astronauts returned with rock samples, scientists discovered something unexpected. Some of those rocks were magnetized. They were not faintly magnetized, but strongly so. It was as if they had cooled within a powerful magnetic field. This made little sense. How could a small body like the moon, barely a quarter the size of Earth, have ever produced such strength? Dynamos require molten metal moving in vast currents. They are driven by rotation and convection. Could the moon, so small, once have harbored such forces? Evidence pointed toward yes. For hundreds of millions of years after its formation, perhaps even longer, the moon may have hosted a dynamo within its core. Heat left over from its violent birth combined with radioactive decay and tidal stirring from Earth. These may have kept liquid iron moving. This generated a magnetic shield. In those days, the moon may have glowed not only with sunlight, but with invisible protection. It shielded its surface from the harshest solar winds. But that dynamo faded. Without enough energy to sustain it, the current stilled. The field collapsed. The moon's shield dissolved into silence. What remains are ghost fields. These are localized regions where ancient magnetism lingers. Unlike Earth's coherent shield, they form scattered patches. Each is tied to rocks that once cooled in the embrace of magnetism. They are fossils of force. They are memories etched into stone. Some of the strangest appear in connection with lunar swirls. These are bright, sinuous markings on the surface. They are visible even from Earth. These swirls, such as the famous Rena Gamma, twist across the soil like painted ribbons. They are brighter than their surroundings. It is as if the dust there has been protected from weathering by solar wind. Indeed, measurements suggest that ghost magnetic fields hover above these swirls. They are weak but sufficient to deflect charged particles. This preserves the soil's brightness. Thus, the swirls are not just visual curiosities. They are active shields. They are born of magnetism that should no longer exist. The opposite side holds its own magnetic oddities. Near the antipode of the South Pole Aitken Basin, scientists found stronger fields. It is as if the colossal impact that carved the basin focused shockwaves. These stirred molten core material. They generated magnetism at the opposite point. It is a strange symmetry. A scar exists in one half. A magnetic echo exists in the other. Here again, the moon's history reveals itself not in light, but in force. It shows itself in invisible patterns that ripple across billions of years. Open questions remain, vast and unresolved. For how long did the moon's dynamo last? Some models suggest it persisted for over 1 billion years. This is far longer than expected for a body its size. Others argue it may have sputtered on and off. It was revived by tidal interactions with Earth as the moon slowly migrated outward. If true, then Earth and Moon together shaped each other's magnetic histories. Their fates were intertwined not just by orbit, but by the flow of iron itself. What of the ghost fields? Why do some regions glow bright with swirls while others remain bare? Are the oddities strong enough to influence future exploration? Will they protect or interfere with instruments? Could humans one day harness them? Could they place habitats where ancient magnetism still deflects radiation? Or are they too faint, too fragile? Are they mere relics fading into geological oblivion? Speculation stretches further. Some dreamers once proposed that the swirls and their magnetic shields might be evidence of deliberate creation. They imagined alien hands sculpting protection into lunar soil. Science finds natural explanations. It points to shock magnetization and solar wind interactions. Yet the idea lingers in imagination. It is fueled by the eerie beauty of the swirls themselves. They look like calligraphy written on the moon's skin. They look like messages in brightness and shadow. Stand upon one of these swirls. You would see no barrier. You would see no shimmering aurora. The soil beneath your boots would simply look lighter, fresher, less weathered. But above you, invisible lines of force twist. They are faint and ancient. They curve against the solar wind. You stand inside a ghost's embrace. It is the residue of a field that once wrapped the entire moon. In silence, you feel history pressing around you. It presses not in stone, but in force itself. The presence of magnetism changes how we see the moon's evolution. It tells us the moon was once more alive than we imagined. Its core was molten. Its heart was stirring. Its shield was real. It also tells us that small worlds can hold dynamos, if only briefly, if only under the right circumstances. This has implications far beyond our companion. If the moon once held a magnetic shield, what of other small worlds? Mercury, asteroids, exoplanets circling close to stars. Their magnetism may be flickers. They may be temporary protections influencing the habitability of planets and moons elsewhere. In this way, the moon's ghost fields are not only relics, but guides. They hint at broader truths about planetary evolution. They tell about how size, heat, and time conspire to create and extinguish magnetic hearts. They remind us that even the smallest body can carry the memory of force as powerful as Earth's own shield. The moon today feels silent, still, airless. Yet in its past it may have glowed with force. It may have been wrapped in an invisible cocoon that left marks we can still detect. Its swirls are signatures of that memory. They are written across dust that resists the ages. Its oddities are echoes of an ancient dynamo. It is long gone, but never fully erased. So as we wander the opposite side in thought, through craters and basins, we encounter not only stone but force. We find a ghostly architecture of magnetism. The moon, it seems, is not just a dead rock. It is a library of invisible fields. It is a keeper of forgotten fire. It is a world that once breathed with molten life. Now it whispers only in patches of preserved brightness. In those whispers lies a message. Nothing is ever truly gone. Force lingers. Memory endures, even in stone. The moon's ghost fields remind us that the past is not erased. It is written in faint lines, waiting for us to listen. In the emptiness above the opposite side of the moon, silence is more than absence of sound. It is an absence of noise across the entire spectrum. It is a pristine hush in radio frequencies that on Earth are forever drowned by the buzz of technology. The opposite side is not only hidden from our eyes, it is shielded from our voices, our transmissions, our endless chatter of signals. In this darkness of communication, scientists see an opportunity. They see a chance to listen to the faintest whispers of the universe itself. Every day, Earth leaks soundless light into space. Radio stations, radar, satellites, Wi-Fi spray outward. An ocean of electromagnetic signals washes even into orbit around the moon. On the side facing us, any radio receiver would be bathed in this artificial storm, but on the opposite side, the bulk of the moon blocks Earth's noise. It leaves a quietness unmatched anywhere nearby. For astronomers who wish to hear the cosmos, this quiet is a sanctuary. Imagine it. A giant stone shield nearly 3,500 kilometers across stands forever between you and the noise of civilization. Behind it, in the shadow on the opposite side, the universe can be heard as it truly is. There is no interference. Here, in that radio silence, lies the chance to tune into signals older than stars. They are older than galaxies. They are older even than light itself. Scientists dream of building telescopes in this silence, not telescopes of glass, but of wire and antenna. They would be sensitive to radio waves with wavelengths measured in meters or kilometers. Such instruments could detect the faint hiss of hydrogen from the cosmic dawn. This was the time before the first stars flared into being. They could probe the dark ages of the universe. This is a period invisible to ordinary light. It was when atoms gathered, cooled, and waited for fusion to ignite. No earthbound observatory could hear this. Our planet's atmosphere blocks long wavelengths. Our own technology smothers them. Only in the silence on the opposite side could such a cosmic song be caught. There have been attempts to prepare the way. Missions like NASA's RA-2, the Radio Astronomy Explorer, orbited the moon in the 1970s. It tested how lunar shielding affected radio noise. More recently, concepts such as the Lunar Radio Array or FARSIDE envision this. FARSIDE stands for Farside Array for radio science investigations of the dark ages and exoplanets. They picture hundreds of antennas spread across the regolith. They would listen not only to cosmic dawn, but also to the magnetic whispers of exoplanets, the storms of distant stars, and the hiss of the intergalactic medium. The beauty of such a sight lies not only in its quietness, but in its permanence. Unlike Earth, the moon has no ionosphere to reflect or distort long wavelengths. Unlike satellites which circle and cannot stay in constant shadow, instruments planted on the opposite side would remain in radio silence every orbit. The moon itself guarantees the quiet. It is an eternal wall against our own noise. Yet practical challenges loom. The same shield that protects silence also cuts communication. A radio telescope on the opposite side would be deaf to Earth's noise. It would also be deaf to Earth's instructions. Any instruments placed there would require relay satellites orbiting above. They would link the hidden half back to mission control. This adds complexity and cost, yet it does not make it impossible. Indeed, China's Chang'e 4 mission landed in the opposite side's von Karman crater in 2019. It relied on just such a relay satellite. Queqiao was stationed beyond the Moon in a halo orbit around the Earth-Moon L2 point. Chang'e 4 was the first step. It proved the principle. We can land, we can communicate, we can explore the opposite side. The dream of radio observatories came closer. There is poetry here too. Imagine building a vast ear in lunar silence, an observatory so sensitive it could hear the echo of the first atoms vibrating across space. It would be like placing a stethoscope to the chest of the cosmos. You would listen to its heartbeat at the very dawn of time. In the silence on the opposite side, we could capture not just distant galaxies but the universe before galaxies. We could hear the moment when light itself first broke the dark. Speculative thinkers extend the vision further. Could the opposite side's quiet become not just a scientific sanctuary, but a cultural one? Could it become a place where humankind preserves silence deliberately? Could it be a cathedral of radio hush dedicated to listening, not speaking? Could it be one of the first international parks beyond Earth? Could it be protected from interference, held in common trust as the world's only perfect ear? Of course, debates linger. Some argue that building on the opposite side could disturb its own silence. Our machines would bring interference where none existed. Others point out that cosmic noise is faint and faintly known. Is it worth the cost to chase whispers when nearer mysteries remain unsolved? Yet for many, the chance to open this untouched frontier is irresistible. The opposite side is more than terrain. It is potential. It is the only natural radio quiet zone within reach of our species. Imagine standing beside such an observatory, though in truth you would not see much. A field of wire antennas would stretch across dust. There would be no mirrors, no domes, no gleaming towers. Above you, the stars blaze. Yet your instrument listens not to light, but to the soft murmur of the void. Somewhere in that murmur is the echo of hydrogen atoms formed 13 billion years ago. Somewhere in that silence is the first breath of the cosmos. The opposite side reminds us that discovery often requires absence, not light but shadow, not sound but silence, not presence but removal. By blocking Earth's voice, the Moon creates the conditions for the universe's voice to be heard. In that silence lies one of the greatest promises of all, the chance to listen not to ourselves, but to the cosmos itself, as it was before we were here to speak. Before humans returned to set foot on the Moon's opposite side, our emissaries are machines. These robots are our scouts, our explorers, our eyes in the silence. They go where no human has yet walked. They carry instruments to measure, cameras to reveal, drills to taste the dust. Though they are only machines, their journeys are among the most poetic chapters in the story of the opposite side. They show us that even in darkness, discovery is possible. For decades after Luna 3's first photographs, the opposite side remained known only from orbit. Every probe that landed, from Luna 9 to Apollo's astronauts, touched the side facing us. Earth's gaze could follow them there. The opposite side was simply too difficult. There was no direct communication. There was no way to guide a lander without losing contact as it descended. The Moon's bulk would block every signal. It would leave a craft blind and Earth deaf. This barrier was broken only recently. In January 2019, China achieved what no nation had before. They made a soft landing on the Moon's opposite side. The mission Chang'e 4 descended into Von Karman crater. This is a vast depression within the South Pole Aitken Basin. To make it possible, engineers first launched Queqiao. This is a relay satellite positioned in a halo orbit around the Earth-Moon L2 point. From there, it could see both Earth and the opposite side simultaneously. Through this celestial mirror, commands flowed outward. Data flowed home. With this clever dance of orbits, the barrier of silence was crossed. The lander carried the Yutu-2 rover. Its name means jade rabbit. The name is steeped in Chinese myth. When it rolled down its ramp and touched the soil on the opposite side, it became the first machine to drive across terrain never seen directly by human eyes. Its wheels pressed into regolith untouched for billions of years. Its instruments began their work. They probed the soil with ground-penetrating radar. They analyzed minerals with instruments that measure light wavelengths. They measured radiation levels in the eternal silence. One of its earliest surprises was the detection of unusual materials in a small crater. Scientists thought these fragments came from deep within the Moon's mantle. If confirmed, this would be the first direct sampling of mantle rock. It would be evidence dredged up by ancient impacts and now examined by robotic eyes. Its radar also revealed layering beneath the surface. Ejecta from impacts was stacked like pages in a book. It recorded a history of bombardment stretching back eons. But Yutu-2 is more than a geologist. It is a survivor. Month after month, it endures extremes unlike Earth's. 2 weeks of searing sunlight bring temperatures soaring above 120 degrees Celsius. This is followed by 2 weeks of darkness, where they plunge below negative 180 degrees Celsius. To live, it sleeps. It curls into hibernation through the lunar night. It awakens at dawn to continue its crawl. Against the odds, it has lasted far longer than expected. It has become the longest-lived rover in lunar history. Each awakening is a small miracle. Each sunrise is a continuation of its slow exploration. Other robotic missions have paved the way as well. Lunar Reconnaissance Orbiter has been circling since 2009. It has mapped the opposite side with exquisite detail. It traces every crater. It measures every shadow. It creates atlases that will guide future explorers. The Grail mission's twin spacecraft traced invisible contours of gravity. They revealed mascons and crustal thickness beneath the rough skin on the opposite side. Together, these orbiters have given us a new understanding. The opposite side is not barren ignorance, but a land known in maps. It awaits footsteps. Still, rovers like Yutu-2 bring intimacy that orbit cannot. They see rocks up close. They measure dust grains. They touch the surface itself. In their silence, they embody our own longing. Each photograph they send is a message from exile. It is a glimpse into landscapes no eye has ever seen. The exploration of the opposite side has just begun. Concepts for future missions abound. NASA and ESA have considered robotic landers to drill into polar shadows. India has studied concepts for probes to the opposite side. China has announced plans for future landings. They plan to return samples from the South Pole Aitken Basin itself. Each mission faces the same challenge: communication and silence. Yet each finds solutions in satellites and relays. The era of robots in shadow is dawning. Speculative thinkers extend these visions further. Could we one day scatter dozens of small rovers? Could they swarm across the opposite side like mechanical insects? Each would map, sample, and relay through a network of satellites. Could autonomous machines dig deep into frozen craters? Could they drill for ice, melt samples, taste chemistry that no sunlight has ever touched? In the silence on the opposite side, such machines could labor endlessly. They would carve knowledge grain by grain, yet there is also fragility. Each rover is vulnerable to dust, radiation, and cold. A single failure can end a mission. In this way, they echo our own fragility. They are fragile explorers in a vast, uncaring landscape. Their endurance becomes symbolic. It reminds us that even delicate instruments can outlast expectation when guided by purpose. If you could stand beside U-22, watching it crawl across the dust on the opposite side, you might feel strangely moved. The little rover with its golden panels and tiny wheels looks almost vulnerable. It sits against mountains that tower like frozen waves. Its tracks are the first in this half. They stretch behind it like a signature. In its smallness, it represents the immensity of our curiosity. Fragile yet persistent, it dares to go where none have gone. The robots in shadow are not the end of the story. They are its beginning. They prepare the way. They map hazards. They reveal resources. They answer questions that human explorers will one day test for themselves. They remind us that the opposite side is no longer wholly unknown. It is known by machines. Through them, it is known by us. In their silence, we hear an echo of our own voices, distant, patient, carried across space. The opposite side is still hidden but no longer beyond reach. The machines we send are our hands in shadow. They are our eyes in silence. They are our courage pressed into steel and solar panels. Through them, the opposite side speaks. For centuries, the moon has been a canvas for human imagination. It is a lantern in the sky. It is a stage for myths. It is a mirror for poets. But as science and technology advance, the moon transforms from symbol into destination. It is no longer just a celestial companion. It is a place we might one day inhabit. If humanity is to build a lasting base upon its surface, there is growing consensus. The opposite side, with all its silence and shadows, may hold the keys to our future. Why the opposite side? At first glance, it seems the least inviting. Communication is blocked. Terrain is rugged. Sunlight is fleeting in polar regions. Yet these very obstacles hide advantages. The permanent shadows on the opposite side hold water ice. This is essential for life. Its peaks of eternal light, ridges kissed by nearly constant sunlight, offer reliable energy. Its radio silence shelters experiments impossible on Earth or in orbit. In paradox lies promise. What seems most forbidding may prove most fruitful. Imagine it. A base nestled near Shackleton Crater. Its rim glows with near-perpetual sunlight. Its floor sinks into frozen shadow. On the rim, solar panels drink in energy. They power habitats tucked within regolith for radiation shielding. Below, machines harvest ice. They melt it into water. They split it into oxygen and hydrogen. Astronauts breathe the air of a world once thought barren. They drink water older than life itself. They venture outward across a land no human has ever walked. Such visions are not fantasy alone. Agencies across the world discuss them openly. NASA's Artemis program speaks of returning humans to the lunar surface. It has eyes on the poles. China has announced plans for a lunar research station. It could potentially be built in partnership with Russia. They target the 2030s. Europe studies modular habitats. These could be inflatable or rigid. They could be buried under dust to shield from cosmic rays. Even private companies dream of lunar mining. They imagine fueling spacecraft with propellant made from polar ice. The opposite side offers more than survival. It offers knowledge. A base there would be a listening post. It would be a scientific sanctuary. Radio telescopes could sprawl across its dust. They would listen to the faint hiss of cosmic dawn. Seismometers planted deep could map the moon's interior. They would resolve mysteries of its crust and mantle. Laboratories could analyze ice cores. They would reveal billions of years of solar wind, comet impacts, and cosmic chemistry. The base itself would be more than shelter. It would be a cathedral of discovery. But challenges remain immense. The silence on the opposite side requires a constant lifeline through relay satellites. Without them, the base would be cut off. It would be stranded in isolation more absolute than any on Earth. Power is abundant on certain peaks but scarce in shadowed craters. Machinery must endure brutal cycles of heat and cold. Dust clings like static. Radiation seeps through everything. To build here is to fight against extremes. It is to turn hostility into habitation. Still, humanity has always thrived at edges. Think of early explorers crossing oceans with fragile ships. Think of pioneers carving homes in deserts. The opposite side is a new frontier. It is harsher than any before, yet it is not beyond reach. With each rover, each orbiter, each crash experiment, we lay groundwork. The first habitats may be small. They may be inflatable modules linked like beads. Perhaps they will house only a handful of astronauts. But from those seeds, outposts grow. Speculative visions stretch further. Some imagine entire cities carved into crater walls. They would be lit by fiber optics channeling sunlight from peaks above. Others see bases on the opposite side as launch pads for Mars. Rockets would be refueled from lunar hydrogen. Their journeys would be shortened by escaping Earth's deep gravity well. Still others imagine scientific sanctuaries. These would be preserved by treaty. Nations would cooperate rather than compete. They would build together in silence for the sake of discovery. What would it feel like to wake in such a base? To step outside in a suit onto soil where no human footprint lies? To see Earth never rise above the horizon? On the opposite side, Earth is absent. It is hidden forever. The sky holds only stars, the sun and the sweep of galaxies. Standing there, you would feel a solitude deeper than any ever known. Yet in that solitude, you would feel connection. Connection to every generation that dreamed of this place. Connection to every explorer who longed to step into shadow. The base would not only be a home for astronauts, it would be a home for instruments, for experiments, for the ambitions of all humankind. Imagine greenhouses warmed with captured sunlight. They would grow plants in regolith mixed with compost. They would be watered by melted ice. Imagine robotic companions crawling across the plains. They would sample rocks. They would build solar arrays. They would extend the reach of human hands. Imagine children on Earth looking upward. They would know not only that the moon is inhabited, they would know that the hidden face now carries voices, breath, and light. Of course, debates will rage. Should we mine lunar ice? Are we consuming a record of history for the sake of progress? Should we preserve the opposite side as a quiet sanctuary? Should we protect its silence for science? Should bases be national or international? Should they be competitive or cooperative? These questions remain unresolved, yet they are questions of abundance, not absence. They arise because the opposite side offers something worth debating. It offers something worth building. The base on the opposite side is not a certainty, yet it is a horizon. Every map, every rover, every discussion of ice brings it closer. It is the logical next step. It is the place where survival, science, and symbolism converge. When it comes, it will mark a transformation. The moon will cease to be a distant companion. It will become a shared frontier. In that moment, the moon's two faces will unite. The side facing us, familiar and gazed upon by poets and farmers, will remain our lantern in the sky. The opposite side, once hidden, will become a place of presence. It will be a home. It will be a laboratory. It will be a threshold to the stars. Together, they will no longer be symbols alone. They will be stages upon which humanity writes its next chapter. Perhaps when we look upward, knowing people live there, the moon will feel less distant. It will feel less alien. It will feel like a neighbor. It will feel like a mirror. it will feel like a promise fulfilled. For in claiming the opposite side, we claim a piece of our own future. Through it, we claim the vastness of the cosmos beyond. Every discovery on the moon has opened not clarity, but deeper uncertainty. The opposite side, revealed through photographs, seismometers, and rovers, is not a solved puzzle. It is a riddle multiplied. For every fact we learn, another question blooms. It is written in the dust. It is etched in the scars of craters. It is whispered in the silence. The moon is a library with pages torn and rearranged. This leaves us to debate what the fragments mean. One of the oldest debates concerns the great difference between the two halves. We know the crust on the opposite side is thicker. Its maria are scarce, its highlands are abundant. But why did radioactive elements concentrate unevenly? They heated the side facing us. They flooded it with lava. Did the collision that carved the South Pole Aitken Basin shift mass? Did it redistribute crustal thickness? Or did the moon once have a twin? Was there a smaller companion that collided gently? Did it spread its body across one half, thickening its shell? Each hypothesis has defenders. Each has model simulations. Yet none has silenced the others. The moon itself withholds the verdict. Another debate circles the age of the South Pole Aitken Basin. Was it carved during the so-called late heavy bombardment 4 billion years ago? This was when Earth and Moon alike were pummeled by a rain of giant impacts. Or is it even older? Is it a relic of a time closer to the Moon's violent birth? Its age matters profoundly. If younger, it reshaped a world already forming crust and cooling. If older, it may preserve chemistry from the Moon's primordial state. It would be a record of the very first collisions that sculpted planets. Dating rocks from its rim might decide. Yet until samples are brought back, the timeline remains blurred. Water ice also divides thought. L-Cross proved its presence, yet how much more lies hidden? Some argue that billions of tons may wait in polar shadows. This would be enough to fuel centuries of exploration. Others caution that the ice may be patchy. It may be mixed in thin grains with regolith. It may be difficult to harvest in bulk. Radar signals suggest abundance in some craters, yet others show barren flaws. Are we looking at vast frozen seas or scattered frost? Until drills bite deep into shadow, the answer is dust and speculation. Even the moon's quakes stir debate. Apollo seismometers heard shallow and deep tremors. Some were powerful enough to rattle structures. But what drives them? Is the moon still shrinking? Is its crust cracking as it cools? Are tidal stresses from Earth flexing its body? Do hidden faults run deeper than we imagine? The opposite side, unmeasured directly, could hold quakes of different character. They could reveal secrets of crust and mantle. Yet without seismometers planted there, we debate in the dark. Then there is magnetism. Some rocks returned from Apollo were strongly magnetized. This suggested a powerful dynamo once beat in the moon's heart. But how could such a small body sustain a dynamo for hundreds of millions of years? Was it tidal stirring from Earth? Was it crystallization of a cooling core? Were impacts jostling molten layers? Each theory explains fragments, yet none explains the whole. Ghost fields remain scattered. Swirls remain luminous. The debate remains alive. Beyond mainstream science, the opposite side has always drawn stranger speculation. Because Earth cannot see it, imagination has filled the void. Some claim alien bases are hidden there. They say these are shielded from our telescopes. Others imagine ancient artifacts preserved in shadow. These ideas lack evidence. Yet they thrive in the fertile soil of absence. The very act of hiding feeds invention. While scientists dismiss such claims, They remind us of the human need to dream where certainty fails. Even the very origin of the moon remains unsettled. The giant impact hypothesis dominates. A body the size of Mars collided with Earth. It ejected material that came together into our companion. But details remain fuzzy. Did the impactor vaporize entirely? Did two moons briefly form before merging? Why does the moon's isotopic composition mirror Earth so closely? It is almost indistinguishable. Some argue the impact mixed materials so thoroughly that both worlds share the same chemical fingerprint. Others suggest the moon formed from Earth's crust alone. Each possibility reshapes our understanding. It changes not just the moon, but Earth's own birth. What unites all these debates is dust. The regolith, fine jagged grains covering the moon, is both barrier and archive. It preserves the history of impacts, radiation, and solar wind. But it also complicates our view. It buries evidence beneath layers. Dust grains record ions implanted by the sun. Micrometeorites melted into glassy spherules. Fragments of distant impacts were carried across halves. Every scoop of regolith holds centuries of story. Yet sorting those stories demands patience, precision, and instruments far beyond what Apollo could carry. The debates are not weaknesses. They are signs of richness, of depth. They remind us that the moon is not a solved equation. It is a living field of inquiry. To study it is to walk a tightrope between certainty and mystery. It is to balance between what we know and what we may never know. The opposite side embodies this tension most of all. It is mapped yet unvisited. It is photographed yet unwalked. It is known yet unknown. Perhaps that is why the opposite side draws us with such pull. Its debates are not only scientific but philosophical. They ask, how do we know what we know? How do we decide between models when evidence is partial? How do we balance exploration with preservation? How do we balance use with understanding? These are questions as much about humanity as about the moon. Imagine future scientists in a base on the opposite side. They drill into polar shadows. They return samples from the South Pole Aitken Basin. They plant seismometers across mountains. Perhaps they will solve these debates with clarity, or perhaps each answer will open new questions. Perhaps they will push certainty further away. That is the nature of science. Dust is never settled, it only stirs. In that stirring lie beauty. The moon is not mute stone but a chorus of voices. Each debate is a note. Each uncertainty is a harmony. Together they remind us that knowledge is not a destination but a journey. It is not a final truth but an endless unfolding. The opposite side, with all its shadows and silences, is a stage where that unfolding continues. It is written not in books but in dust. When we gaze at the moon's opposite side, we see more than a landscape of stone. We see a mirror. It is a surface that reflects our questions, our ambitions and our fears. Every crater and basin, every patch of ghost magnetism or frozen ice echoes back the story of humanity itself. It echoes our desire to reach beyond. It echoes our struggle with mystery. It echoes our hunger for meaning in the silence. The opposite side is not only science, it is myth reborn. For thousands of years, the moon was whole in our imagination. It was always turned toward us. It always glowed with its familiar face. The hidden half belonged to stories, to speculation. Some imagined gods lived there. Others imagined demons. Even in modern times, conspiracy theories cloaked it with secrets. They spoke of alien bases, artifacts, lost civilizations. Though none of these claims bear evidence, their persistence shows how deeply we project ourselves onto the unknown. What we cannot see, we fill with imagination. Now, science replaces speculation with data. yet the wonder remains. High-resolution maps, seismic readings, mineral surveys, and rover tracks do not diminish mystery. They deepen it. For in every fact lies another layer of unknown. Why does the crust thicken here? Why does ice survive there? What do ancient impacts whisper about Earth's own early days? The moon does not shrink under scrutiny. It expands. With it expands our sense of place. The moon is not separate from us. Its tides have sculpted Earth's shores. They have guided migrations. They have influenced rhythms of life. Its very existence may have stabilized Earth's axis. This allowed climate to remain stable enough for life to flourish. To study the opposite side is not to study another world alone. It is to study the conditions that made this world possible. Each crater is a reminder of impacts that Earth also endured. Each fragment of mantle rock hints at the same forces that shaped our planet's depths. The story of the opposite side is inseparable from our own. Yet there is more than science in these echoes. There is philosophy. The opposite side challenges us to think about visibility and absence. It makes us consider what it means to live always facing one side while hiding another. Earth never sees the opposite side. The opposite side never sees Earth. They are bound in orbit yet estranged in view. Does this not mirror something within us? Parts of ourselves are always visible. Others are hidden, known only in silence. The opposite side becomes metaphor as much as geography. It is a reminder that every world, every person has a hidden half. This is why the idea of a future base on the opposite side carries such symbolic weight. To live there would be to step into humanity's own shadow. It would be to bring light to what was hidden. Astronauts would not only conduct experiments, they would embody a shift in perspective. Imagine their transmissions. They would not have Earth in their sky, but the Milky Way stretched unbroken. It would be a reminder of our smallness and our belonging. Their presence would tell us nothing remains forever hidden. Not even the opposite side of the moon. The echoes extend outward too. An observatory on the opposite side listening to radio silence would capture the universe's first whispers. These are signals from before galaxies formed. These are not just measurements. They are humanity's ears pressed against the cosmic womb. We listen for the moment when structure emerged from chaos. In those faint signals lies a story older than stars, one that connects us to the very birth of time. Humanity's search for meaning finds resonance here. In listening, we hear not just the universe but ourselves asking across epochs, where do we come from? Still, speculation persists. Perhaps in those polar shadows where ice lies undisturbed, organic molecules may slumber. Perhaps in those magnetized swirls, secrets of cosmic processes remain encoded. Perhaps the opposite side is not only a destination, but a library. It is a vault of stories waiting for us to read. The echoes are not only scientific, but existential. They tell us you are part of something older, larger, more mysterious than you can imagine. Even the silence itself is an echo. On the opposite side, cut off from Earth's noise, one could stand beneath the stars and hear nothing. No transmissions, no chatter. Only the hum of your own suit. Yet in that silence, paradoxically, you might feel connection. Connection to every explorer who braved uncertainty. Connection to every thinker who wondered what lay unseen. Connection to every dreamer who looked up at the moon and imagined. Silence becomes voice. Absence becomes presence. The opposite side speaks not through sound but through what it withholds. Humanity is still at the threshold. Rovers crawl, orbiters scan, yet footprints remain absent. Still, the opposite side already echoes in our culture. Poets write of it, artists paint it. Children ask why we cannot see it. Its very hiddenness stirs imagination across generations. When we finally stand there, we will not only claim new territory, we will fulfill an ancient yearning. We will turn myth into memory. Perhaps that is the deepest echo. The reminder that exploration is not about conquest, but about reflection. In reaching the opposite side, we do not simply uncover another half of the moon. We uncover another half of ourselves. The part that seeks, the part that wonders, the part that refuses to leave mystery untouched. The opposite side is stone, dust, silence. Yet it is also echo of creation, echo of impact, echo of humanity's unending curiosity. To walk there is to walk not only on alien soil, but in the resonance of every question we have ever asked. Questions about who we are and where we come from. The opposite side becomes not a place apart, but a place within. A mirror, a reminder, a voice in silence that belongs to us all. The journey across the moon's hidden half is not only a trek through stone and silence, it is a passage through the edges of human imagination. We began with photographs, grainy and miraculous. They revealed mountains and craters no eye had seen. We advanced with orbiters. They peeled back maps of gravity and magnetism. They uncovered ice frozen in vaults of shadow. We sent rovers into the dark. These were machines that crawled where no footprint lies. Through each step, the opposite side has shifted. It has moved from mystery into intimacy, from speculation into science. Yet it never surrendered its aura of the unknown. Now we stand at the edge of a horizon. It is not of geography, but of time. What does it mean to have revealed the opposite side? What does it mean for humanity to contemplate living there? To contemplate building bases? To contemplate listening to the universe from its silence? This horizon is not a border we cross once. It is a new threshold of possibility stretching into the centuries to come. The final horizon begins with survival. To live on the opposite side, humanity must master extremes. Heat and cold swing like a pendulum. Radiation seeps invisibly. Dust cuts and clings. Silence isolates. Yet in each danger lies potential. Ice becomes water. Shadow becomes resource. Silence becomes sanctuary. The very features that make the opposite side forbidding are the ones that make it invaluable. Our challenges are our opportunities. If we learn how to shape them, from survival grows permanence. A single habitat becomes an outpost. An outpost becomes a base. Over time, what begins as fragile modules could grow into cities. They could be carved into crater walls. They could be illuminated by fiber optic sunlight. From these strongholds, humanity could launch expeditions deeper into the solar system. Mars, asteroids, beyond. They would be fueled by propellant mined from lunar hydrogen. The opposite side, once the hidden half, becomes a gateway to the stars. But this horizon is not only practical, it is cultural, philosophical, even spiritual. Imagine standing on the opposite side and looking up. Earth never rises. It is absent, forever hidden. In its place is a sky unbroken. The Milky Way stretches from horizon to horizon. Galaxies shimmer in numberless hosts. For the first time, humans would live in a place where Earth is unseen. Our planet would not be the constant companion, but the hidden presence behind stone. To dwell here is to reshape perspective. It is to learn what it means to be human when the familiar anchor is gone. This absence may bring clarity. To live without Earth in the sky is to feel small, yet also vast. You are a part of the universe, not tethered to constant reminders of home. It may inspire new art, new poetry, new ways of seeing ourselves. Just as astronauts gazing at Earth from the side facing us spoke of the overview effect, perhaps those who live on the opposite side will speak of the absence effect. It will be the revelation of what it means to belong when the mother world is hidden. Speculation stretches further still. Could the opposite side become not only a scientific base, but a cultural sanctuary? Could it become a place preserved for silence? Could humanity protect the absence of noise as a heritage, just as we protect forests or oceans? Imagine international treaties designating the opposite side as a reserve for listening. It would be a cathedral where radio telescopes hum quietly. They would be tuned to the faintest echoes of cosmic dawn. It would be a new kind of monument. It would be built not of stone, but of silence. It would be dedicated to wonder. Beyond science, beyond culture, lies mystery. The moon is still not finished telling its story. We have yet to drill deep into polar ice. We have yet to return samples from the South Pole Aitken Basin. We have yet to map its deep interior with seismometers spread across both halves. Each of these will answer questions, yet each will open more. Perhaps we will learn that the moon formed in ways we have not yet imagined. Perhaps its ice will reveal ancient molecules. Perhaps they will be fragments of cosmic chemistry untouched for billions of years. Perhaps even its silence will carry surprises we do not yet know how to detect. The final horizon of the opposite side is not an ending, but an opening. Standing at that threshold, we sense the arc of human story bending outward. Once we feared the night sky, we filled it with myths. Then we mapped it with telescopes. We reached outward with imagination. Now we prepare to step into it, to live not just beneath the stars, but among them. The opposite side of the moon is the next step. It is the quiet shadow that leads to the blaze of greater journeys. As this story winds down, we slow our breath. The pace softens. The vast craters we have crossed fade into distance. The icy shadows grow dim. The bright peaks quiet. The echoes of magnetism dissolve. What remains is a feeling of silence, of wonder, of connection. The moon is no longer the stranger it was. It is companion, partner, teacher. As you rest now, imagine yourself lying upon its dust. Above you, stars shimmer without trembling. Galaxies wheel in silence. No sound reaches you but your own heartbeat. Steady, slow. You are part of the cosmos, as ancient as the moon, as young as the dawn. In the stillness there is no fear, only belonging. Let go then. The moon watches. The stars sing softly. The universe breathes around you. You are safe in its silence, safe in its light, safe in its shadow. Sleep carries you gently, like tides pulled by the moon itself.